Hi guys, welcome to a new episode of MrLopezClasses.com. In this episode, I am going to explain why zinc is used to protect other metals. Why the people protect the boat, protect the metallic part of the boat with pieces of zinc. For example, those are the zincs used on the shaft of the propeller. And this is one of the zinc completely eroded. That piece of zinc was used on the flaps of the train taps. Today I am going to explain why zinc is a special metal used for that purpose. But the only way to explain in a simple way why zinc is a perfect protector is if I explain the fundamentals, the chemistry of the metals. Let me start from the beginning. All the elements are composed by atoms. The matter is the fundamental, and the matter is composed by atoms. If you check the definition of matter, all matter is made of atoms composed of protons, neutrons, and electrons. The center or nucleus of the atom is composed by protons and neutrons. And in the orbits, you have the electrons. It's exactly the picture that you have in this moment. You have in the center, you have protons and neutrons. And you have in the orbits, the electrons. This is basically the composition of the atom. Normally, I say that the atom is like a small solar system. With the sun in the center, that's the nucleus, protons and neutrons, and the planets around the sun, in this particular case, are the electrons in orbits around the nucleus. It's exactly the same. It's like a small solar system. Remember, in the nucleus is the sun. The nucleus is composed by protons and neutrons. And in the orbits, you have the electrons. This is basically the composition of the atom. Let me check quickly how the atom is the nomenclature to specify the atoms. In order to understand how the elements are organized in the periodic table, why some elements are located here and other elements over there and other. Why? What is the reason? For what reason we have the radioactive elements in the bottom? What is the organization? Who invented that organization? Okay, the inventor was Dmitri Mendeleev, a genius. A genius. He organized the periodic table in this way. And until today, this is our path. This is the path for engineers in order to work with metals, with materials, with composed components. That's the only way, the periodic table. Okay, the periodic table have two numbers. One number on top. In this particular case, we are going to talk about helium. And in this particular case, the top number is 2, and the bottom is 4. Let me explain what is the meaning of that. The top one, number 2, is related with the atomic number. The top number refers to the number of protons or number of electrons. If we return to this picture, the atom have in the structure the same amount of protons and the same amount of electrons. For example, in this particular case, if this atom have 1, 2, 3, 4, 5, 6 electrons, then in the nucleus there are 6 protons. In other words, all the atoms are internally stable. The same amount of protons in the nucleus are equal to the amount of electrons in the orbits. That's the most important part. That amount of protons or electrons is the atomic number. right? The bottom number in the specification, this one, the bottom number 4, refer to the amount of protons and neutrons on the nucleus. For that reason, the bottom number normally is double than the top one, or a little bigger, like in this case. In this case, the bottom number, the atomic mass, is 6.9, and the top is 3. What is the meaning of that? This element, lithium, have 3 electrons. Lithium have 3 electrons. And the atomic mass is 6.9. This is the amount of neutrons and protons. Remember, all the atoms, they have the same amount of protons and electrons. What about the neutrons in the nucleus? The neutrons normally should be the same amount of protons, but in some cases there are more neutrons. Remember, the charge of the neutrons is neutral. Only affect the weight. Only affect the weight of the element. For that reason, there are elements too heavy, like lead. No, it's because in the nucleus, lead have a lot of neutrons. Okay, in the nucleus, you have protons and neutrons, and the atomic mass refer in relation to the number of protons and neutrons. The atomic mass of weight of an atom is determined by the number of protons and neutrons in the nucleus. The electrons are small in terms of weight in comparison with the protons. The protons have 1,800 times the mass of the electron, but exactly the same size in charge. The charge is equal but opposite. The protons is positive and the electrons negative. All right? In the orbits we have electrons. The amount of electrons should be equal to the amount of protons, and in the nucleus I have protons and neutrons, normally more neutrons than protons. That amount of protons and neutrons is the atomic mass. All right, this is the most important part in relation with the atom. And now I am going to explain how the periodic table is organized. The elements are organized in the periodic table. According with the amount of electrons in the orbits, the most important part is how many electrons have the atom in the last orbit, in the outer orbit. Depending of the amount of electrons in the outer orbit, the electrons are located in the periodic table. And the elements are organized in the periodic tables in groups, verticals, those are groups, and there are main groups and subgroups. The main groups are group number 1, group number 2, group number 3, group number 4, 5, 6, 7, and 8. Those are the main groups. 1, 2, 3, 4, 5, 6, 7, and 8. I'm going to explain right now why 8 groups. And those are subgroups. All right. In the group number 1, are located all the elements with 1 electron in the last orbit. All of those elements located in the group number 1, they have 1 electron in the last orbit. Hydrogen have only 1 electron. What is the meaning of that? Hydrogen only have 1 orbit with 1 electron. How many protons have hydrogen in the nucleus? Only 1 proton. Oh, let me explain sodium. Sodium have 11 electrons. 11 electrons in the last orbit? No. 11 electrons in total, in different orbits. But in the last one, only have 1. For that reason, it's located here in group number 1. That's clear? In total, 11. But in the last orbit, only 1. For that reason, it's located here. Oh, let me check magnesium. Oh, magnesium. How many electrons in total in the orbit have magnesium? 12. Okay, 12. But how many electrons have magnesium in the last orbit? Only 2. For that reason, it's located in group number 2. Let me check aluminum. Aluminum is located in group number 3, in the principal group number 3. How many electrons have aluminum in total? Oh, aluminum 13. 13, but only 3 in the last orbit. All of those elements have 3 electrons in the last orbit. What about phosphorus? Phosphorus is located in group number 5. Phosphorus in total have 15 electrons in different orbits. But in the last one, only 5. Only 5, for that reason, is located in group number 5. Let me explain something. All the elements try to complete in the last orbit. The maximum amount is 8 electrons in the last orbit. This is the Octet Rule. Let me explain what is the meaning of the Octet Rule. The Octet Rule states that all the atoms want to have 8 electrons or 0 in the outer orbit or valence orbit. All the elements try to complete 8 electrons in the last orbit or 0. That's the Octet Rule, and I am going to explain right now what happened in that case. When one element have 8 electrons in the last orbit, that element is considered stable. What is the meaning of that? That element is considered that not react with any other element. And that element with 8 electrons in the last orbit is considered a noble element. For that reason, the element located in this group, in the group number 8, they are called noble gases. They don't react. Helium, neon, argon, krypton, xenon, radon. All of those gases are stable, not react. For that reason, you remember the welding procedure with argon, the MIG and TIG? What gas is used in the procedure, in the welding procedure, MIG and TIG? It's used argon. Argon is a noble gas, is an stable gas. What is the function of that gas during the welding procedure? The argon produces a bubble of argon, and the oxygen no enter over there and never attack the welding area, never oxidize the welding area because the argon produce a bubble. The argon is stable, and the oxygen no pass over there, no enter over there, and you can weld in a clean area, in a clean and professional area. In the moment that you apply the gun in the MIG welder, the electrode goes in the middle out, and argon sprays around the electrode and protect the area. This is a noble gas. In the last orbit, 8 electron is full stable. All right? Okay. The elements are located in the periodic table according with the amount of electrons in the last orbit. It's simple. Number 1, number 2, 3, 4, 5, 6, 7, and 8. All right. According with the amounts of electrons in the last orbit, the elements are considered with more energy or less energy. In other words, the elements with 1 or 2 electrons in the last orbit, the elements located here, they are considered elements with low level of energy. The elements located in the high, in those groups, 6, 7, 5, 6, 7, are considered elements with high level of energy. That's the explanation. Okay, what happened normally with the elements with high level of energy? The elements with high level of energy, they try to attract, for example, oxygen. Oxygen in what group is located? It's located in group number 6. Oxygen normally try to attract 2 additional electrons because oxygen has 6 electrons in the last orbit, only need 2 to be stable. For that reason, oxygen try to get those 2 extra electrons from any metal on the environment. For that reason, oxygen oxidizes everything, because oxygen have high level of energy, is located here, and the rest of the elements are located over there. And oxygen have more energy and can attract the rest of the element from the environment. Okay, the elements located in this area with high energy are considered elements with high electronegativity. And the elements located here in the bottom, in the left side in the bottom, are considered elements with low electronegativity, with low energy. What is the meaning of electronegativity? Let me check what is the meaning of electronegativity. Electronegativity is here. Electronegativity is a measure of the tendency of an atom to attract electrons, like I explained before. Okay, what is the element in the periodic table with the higher level of energy or higher level of electronegativity? This one, fluorine. Fluorine. What is the value of the level of energy for fluorine? 4.0. It's like a millivolt. It's the level of energy of fluorine, 4.0. And what is the element in the periodic table with the lower level of energy? Is francium in this corner with 0.7. It's a little amount of energy. And the rest of the elements have energies in between. In this table, I have the table with the values of electronegativity. If you can check in this table, for example, fluorine is 4.0. Oh, oxygen 3.5. Oh, let me check aluminum 1.5. Let me check francium 0.7. Yeah. The elements located in those groups, group number 1 and group number 2, they are the elements with low level of energy. And the elements located in those groups, they are the elements with high level of energy. This is important in order to understand later how the molecules are created. This is very important, because this video clip is only to understand why zinc is the metal used to protect the other metals. In order to understand that phenomenon, I need to explain these fundamentals of chemistry. Okay. Right now, it's clear what is the meaning of electronegativity. Electronegativity is basically the energy of each element. There are elements with more energy because those elements have more electrons in the last orbit. And there are other elements with low level of energy because those elements have a less amount of electrons in the last orbit. In the last orbit, doesn't matter if in the other orbits have more electrons. The most important is the amount of electrons in the last orbit. All right? Okay. All right. That's what is the meaning of that. The elements with more electronegativity, with more energy in the future will be the oxidizers. And the elements with low level of energy in the future will be the reducers. The element with high level of electronegativity in the future will be the element that attract electrons. And the element with low level of electronegativity will be the element that release electrons in the creation of molecules. That's very important. The element that attract will be the cathodes, and the element that release will be the anodes, sacrificial anodes. Yeah, we are on the way to understand that phenomenon. All right, that's the procedure to organize. And now let me explain how can I create molecules. What is the meaning of molecule? Molecule is the combination of two elements. Doesn't matter if both of them are equals or dissimilars. When you combine two elements, you create a molecule or a compound. A molecule is formed when two or more atoms are connected together chemically. A compound is a molecule that contains at least two different elements. A compound is a molecule that contains two different elements. All the compounds are molecules, but not all the molecules are compounds. Forget that. This is not critical. Okay, the molecule is basically when you have two different elements together. That's it. Okay, let me explain example of molecules. Molecules stable. Give me an example of a molecule that is completely stable. What is the meaning that is stable? No react. Let me check examples of molecules that are completely stable. Let me check examples of molecules that are completely stable. For example, I am going to create here a molecule of water. What happened with the molecule of water? Let me try to check what happened with water. All right. Water is oxygen and 2 hydrogens. Let me I make a drawing about that molecule, the molecule of oxygen and hydrogen. All right. How many electrons have oxygen in the last orbit? Oxygen in the last orbit have 6 electrons. Okay. Let me check. 1, 2, 3, 4, 5, and 6. Remember about the octet rule. What states the octet rule? That all the elements try to complete 8 electrons in the last orbit or 0 in order to be stable. Okay, good, very good. How many electrons have hydrogen in the last orbit? Hydrogen in the last orbit only have 1 electron. What element in between oxygen and hydrogen have more electronegativity or high level of energy? According with the periodic table. Oxygen is located here. And hydrogen, here. Of course, oxygen have more level of energy, more electronegativity. Okay, in that case, oxygen in the future attract electrons from hydrogen, and hydrogen release. Okay, hydrogen release this electron, and the other hydrogen release the other one, and at the end of the day, oxygen complete 8 electrons, hydrogen completes 0, and the other hydrogen 0, and the molecule is stable. What is the name of the molecule? H2O, and this is water. Water is a perfect molecule. Water is a molecule fully stable. For that reason, water never reacts. Water all the time is neutral, is perfect. This is good. This is perfect. Let me try to create another molecule or compound stable. Try to think in the environment other molecule that is stable. What about the oxygen that you breathe? The oxygen that you breathe is the molecule is O2. And is stable that molecule? Yes, it's stable. Let me check why that molecule is stable. I have 2 oxygens. And each oxygen with 6 electrons in the last orbit. And I have the other oxygen here with 6 electrons in the last orbit. What is the situation in this case? They share a couple of electrons. And all the time, both of them have 8 electrons. That relation is a covalent reaction. And the previous one, this one is ionic reaction. We are going to learn later in our class of corrosion that this relation is permanent. The ionic reaction is permanent. And what about this one, the covalent reaction? This is temporary. Okay, it's temporary. What is the meaning of that? This is important. For that reason, the oxygen in the environment, that relation in between 2 atoms of oxygen is not permanent, it's not strong, it's temporary. For that reason, in the environment, it's easy to separate those 2 oxygens. What happens when those 2 oxygens are separated? The single oxygen goes up and create ozone. Remember, we are going to study later in our class of corrosion, there are 2 types of ozone. The ozone that is close to the surface of the earth is a bad ozone, is corrosive. And the ozone that is located outside of the stratosphere is a good ozone because reflects the X-rays and other radiation. For that reason, if you destroy the molecules of oxygen at this level, the single oxygen goes up, try to goes up, but immediately is attract for other elements like fluorine or chlorine and create corrosive particles we are going to study later. Yes, O2 is an unstable compound or a stable molecule. It's not strong because the relation in between both of them is covalent, it's not ionic. There are millions of molecules stables, and we are going to study some of them right now in this video clip. Okay, it's clear that's the creation of molecules, and now I am going to explain this is other molecule, the molecule of carbon dioxide and carbon monoxide. What do you think? What molecule is stable? Carbon dioxide or carbon monoxide? Yes, it's stable, carbon dioxide. It's not stable, carbon monoxide. What is good for the environment? Carbon dioxide or carbon monoxide? It's good, carbon dioxide, because it's stable. Carbon monoxide is not good. Let me explain why carbon monoxide is not good. We are going to check carbon dioxide, CO2. All right, I am going to check one carbon here in the middle with four electrons in the last orbit, because carbon is located here in group number 4. And I am going to draw 2 oxygens, and each oxygen with 6 electrons in the last orbit. Each oxygen with 6 electrons in the last orbit. Okay, 6 electrons in the last orbit. Okay, let me check what is the element with more energy. Oxygen, because oxygen is in group number 6. And the element with less energy is carbon. Okay, what is the meaning of that? Right now, in this relation, oxygen tries to attract the electrons from carbon in order to complete A in the last orbit. Oh, that's the situation. Those electrons from the carbon goes here, and the other one goes over there because oxygen have more energy. This one completes 0, this one completes 8 and 8, and right now the molecule CO2 is a perfect stable molecule. What happened with the molecule of CO, carbon monoxide? CO, carbon monoxide. I have only one carbon and only one oxygen. Let me check the oxygen with 6 electrons and the carbon with 4. Those two goes here. But what about these ones? That molecule is stable? No, that molecule is not stable because there are two electrons free, and those two electrons from the carbon in the environment try to separate molecules of oxygen, try to separate the O2 in order to stabilize the equation, but the single oxygen produce pollution, because the single oxygen will be attracted from fluorine, chlorine, or sulfur and create molecules not good for the environment. Yes, carbon monoxide is not good. Let me explain something. What is the source of carbon monoxide? Carbon monoxide is produced in the exhaust pipe of the majority of the engines, gas or diesel. Yes, if you check in the exhaust pipe, there are a lot of carbon monoxide molecules. Those molecules are not good for the environment. What happens if you have your car with the engine on in the garage of your car, and you close the door of the garage and you stay in your car with the engine on sleeping? What happens with you in 5 minutes? You died. Why? Because you breathe carbon monoxide, and the carbon monoxide enter in your body, and the carbon monoxide absorb the extra oxygen necessary to complete the equation from your blood. And in 5 minutes, 6 minutes, your blood is with 0 oxygen and you die. Now you understand why the people died when the people is sleeping in the cars in a closed area with the engine running. That's the reason. Because the carbon monoxide enter in your body and absorb the oxygen from the blood. What happened when the level of oxygen decrease in the blood? What happened when the blood enter in your brain with no oxygen? Finito. And you left. All right. That's the explanation for those molecules. And now I have the theory ready to explain what happened with zinc. Why zinc is excellent to protect other metals in your boat. Why the people use the zinc like the sacrificial anode. All right? Okay. The elements located in this group, in the yellow group, in between this and this, they are called transition metals. Okay, let me explain before this. The periodic table have one division. Look at this division. You see the division? That division. The elements in the periodic table located below the divisions are called metals. And the elements located over the division, they are called non-metals. Metals and non-metals. All the elements located here are metals. Oh, aluminum is in the limit, but it's metal. And all of those elements located here are metals. Let me check the rest. Oh, iron. Oh, chromium, magnesium. Oh, nickel, copper, zinc, cadmium. All of those are metals, except hydrogen. Hydrogen really should be located here because it's a gas. But because only have one electron in the last orbit, it's located here. This one should be located over there, but the rest are metals. Oh, sodium is metal. Yes, it's a metal. Magnesium is a metal. Calcium is a metal. All of those, potassium is a metal. All right? Those are metals, and those are non-metals. Okay, the element located here, only one electron in the last orbit. Here, 2. Here, 3, 4, 5, 6, and 7, and noble gases, 8 in the last group. What about this group? In this group, the elements located in between this and this, they work with 3 electrons in the last orbit. And this group, this small group, zinc, cadmium, and mercury, they only have 2 electrons in the last orbit. Only 2 electrons in the last orbit. The rest of the metals, copper, nickel, iron, gold, silver, all of those, they work with 3 electrons in the last orbit. This is very important. This is very important. How many electrons have oxygen in the last orbit? 6. How many electrons need oxygen to complete 8? 2. Okay. Suppose that oxygen have in front 2 metals, copper and zinc. What element for the oxygen is better to attack? The copper or the zinc? Let me check. If the oxygen attack the zinc, immediately complete 8 and finish. Finito. If the oxygen attack the copper have 3 electrons in the last orbit, and the oxygen need 2. Immediately the oxygen need call other oxygen, and the copper call other 2 additional coppers in order to create this molecule. The molecule this is the oxide of copper. This is the oxide of copper. What about if the oxygen try to attack the aluminum? Exactly the same. Exactly the same. There are necessary two molecules, two atoms of aluminum and three atoms of oxygen in order to create the oxide of aluminum. It's complicated. What happened when the oxygen attacked the zinc? When the oxygen attacked the zinc, immediately the situation is this. When the oxygen attacked the zinc, the oxygen have 6 electrons in the last orbit. And zinc 2. What happened? What element have more energy? Oxygen. What element have less energy? Zinc. Immediately the oxygen attract the 2 extra electrons and the zinc release those 3 electrons. What is the name of the element that release the electron, that donate the electrons? This is the anode. This is the anode. And what is the name of the element that attract the electrons? This is the cathode. This is the cathode. What is the charge of the cathode? Is negative. What is the charge of the anode? Is positive. Why the anode is positive? Yes, because in this particular example, zinc released 2 electrons. When the element release negative charge, become more positive. And what about the other one? The other one attract 2 extra electrons. Right now the charge is more negative. The element that release will be at the end of the day more positive. What happened when the element release electrons? Internally in the structure of the metal, when the metal release 1 electron, 1 small hole is produced because the electron jumped outside and produce a hole. What happened when the element release and release and release electrons? A lot of holes are produced, and at the end of the day, the piece of metal is completely corroded. How many holes have this piece of zinc that is completely eroded? Millions of holes is completely eroded. In this moment, this piece of metal is not zinc. It's oxide of zinc because the oxygen attacked the metal and produced this oxide. If I move this one with my hand, it's like a sand. This is oxide of zinc. This element is completely eroded. Now I understand why if I have the rudder in my boat, what is the material of the rudder? You remember? It's a copper alloy. Normally it's bronze. You remember in our class of introduction, it's bronze or naval bronze or nibral. Okay, that alloy, that copper alloy could be protected with a piece of zinc. If I put one piece of zinc like this in the rudder, the oxygen attack the zinc and the copper will be protected. For that reason, each 6 months, I need replace the pieces of zinc for new pieces of zinc in order to protect the copper. Let me explain that situation in this way. I explain the phenomenon of zinc, like a protector of other metals, with a funny example. Suppose that you have a party for kids, little kids, and the party is in this room, and I have 3 groups of tables, and the door is in this corner, and I am going to organize the room for the party, and I am going to put in the group of tables in the middle only donuts of a lot of sugar, strawberry donuts in the middle. And in the group of tables on the left side, I am going to locate vegetables, broccoli, vegetables. And in the group of tables in the other side, I am going to put place with fruits. Okay. Ready? I have 3 groups, vegetables, donuts, and fruits. And I am going to open the door of the room right now. And the kids enter in the room. What group of tables disappear in fraction of seconds? The middle ones with the donuts. The donuts disappear in 2 minutes. Okay. What is the next group of tables in preference for the kids? Okay, the fruits. A lot of bananas. Okay. And what is the last one? The vegetables. All right. What is the meaning of that? In our boat, if I am the oxygen and I am checking in the bottom of the boat is on the water, and I am the oxygen on the water, I want to attack that boat. Let me check what is the metal that I love it. What is the donut for me? Oh, the zinc. And I go and I attack the zinc where I have zincs in a typical boat. Oh, I have zincs on the shaft. I have zincs at the end of the propeller. I have zincs on the rudder. I have zincs on the flaps of the twin tabs. Yeah, those are the most common zincs. And of course, I have the main zincs on the transom of the boat. The oxygen attack all of those things, and the rest of the metals, the shaft in perfect condition, the propeller in perfect condition, the rudder in perfect condition, the flaps in everything in perfect conditions, because the oxygen attack the pieces of zinc. Nice. What happens when the zincs are fully eroded, completely eroded? Of course, if the zincs are gone, the oxygen starts to attack the vegetables slowly, and the copper will be corroded, the steel will be corroded, slowly, but will be corroded. For that reason, you need to keep your zincs like new ones, in perfect conditions, in order to protect the other metals. Is clear? Okay. I have a question. One of my students said, what happened with the metals located in the group number 2? What other metal can be used the same like a zinc? What other metal have the same properties of zinc? Other metal with similar properties is magnesium. What about the other metals? The other metals, calcium, strontium, beryllium, those metals react in contact with water. For that reason, those metals are no good. Magnesium is good. Magnesium have excellent properties to protect other metals in fresh water. In our book of corrosion, in our class of corrosion, I explain in details why magnesium is recommended for fresh water, for lakes. If your boat will be working in fresh water, you need to protect the metals, you need to protect the boat, the bonding system, with metallic pieces of magnesium. Magnesium is good for fresh water. Zinc is the preferred anode of protection in saltwater environments. All right. And some people is talking about aluminum. All right. Aluminum in brick water probably is good, is a good protector, but it's not pure aluminum. There are some alloys of aluminum, aluminum with cadmium. Oh, those metals, zinc, cadmium, and mercury, it's supposed that they have the same properties of zinc. What happened with cadmium? With cadmium, there are two problems. One problem is poison. That's the first one. And the second one is too expensive. Cadmium have other ability. Cadmium have the ability to store a lot of electrons, similar to lead. You remember the batteries? Yes, cadmium have the same ability. For that reason, there are batteries fabricated in lithium, and cadmium, and other batteries in lead. Yes, cadmium is used to fabricate batteries because have the ability to store a lot of electrons. But the problem with cadmium is poison, and it's too expensive. Zinc is expensive? No. And there are a lot of zinc a lot of zinc on the Earth. For that reason, zinc is the preferred material used to protect against corrosion in marine environments. Zinc is excellent in saltwater environments. Magnesium is good in freshwater environments. And some alloys of aluminum with cadmium and other metals, I'm going to explain in the book of corrosion that situation, are excellent for brick waters. All right, this is the situation, and for that reason, zinc is the metal for preference in order to protect against corrosion. But be careful with this before I finish this video. The oxygen prefer attack the zinc. For that reason, in the future, in other episodes of other books, we are going to talk about two non-ferrous alloys used in marine applications. One of that ferrous alloys is monel, and other one is nibral, and other one is bronze. But some people say, oh, Mr. Lopez, also brass. No, brass, no. Brass is a copper alloy with high content of zinc. That alloy attracts the oxygen because the amount of zinc. And that alloy, at the end of the day, will be affected. And that alloy is not recommended in marine environments. For example, if you try to buy copper fittings for plumbing, for water system or fuel systems, the copper fittings that you buy in general storage, in construction storage for residential purposes like a Home Depot, those fittings are fabricated in brass. Those fittings are not marine approved. The fittings approved for marine environments are fittings in bronze or naval bronze. Bronze for marine environments. Bronze, no brass. Brass is not accepted, ABYC question. And other important situation that I am going to explain later is the combination of dissimilar metals in marine environments. There are two elements that in marine environments, they are no good friends. Is copper and aluminum. Copper and aluminum together, you remember galvanic corrosion, both of them together in a marine environment, the more noble attacks the less noble, and the less noble will be corroded. This is not good. This is not good. We are going to study later why copper fittings in aluminum tanks are not accepted. Copper and aluminum is not accepted in a marine installation. Okay, be careful with that. And the last one, in order to finish this video clip. When you have a molecule, one element with other one, for example, the oxide of zinc, what is the anode in the oxide of zinc? Oh, oxide of zinc is zinc and oxygen. The oxygen attract and the zinc release. Okay, the zinc is the anode, is the positive terminal. And the oxygen attract is the cathode. Oh, the element that release the electrons normally is the less noble, is the sacrificial anode. And the element that attract is the cathode. Is the element that at the end of the day will be more negative. Okay, the anode is the sacrificial anode because the anode, each time that release electrons, become more positive and it will be eroded. Don't forget that. The anode is the positive terminal and the cathode is the negative. You remember when I explained the batteries? The positive terminal of the battery at the end of the year is completely eroded because it is constantly releasing electrons. And the cathode only received is in perfect condition. Okay? Don't forget, the anode is the donor and the cathode is the absorber. The cathode is the negative and the anode is the positive. I hope you enjoyed this video. I hope that right now is clear for yours why zinc is the preferred metal to protect for corrosion to other metals. Thank you.